Last week, we were investigating angle pair relationships that only occurred when you had a set of parallel lines cut by a transversal. This week, we are exploring a relationship that only occurs when you have a triangle with a right angle in it. So these special triangles are called right triangles. Pythagoras' theorem says that if you take the square of the two shorter sides, so square this side and square this side, and add them together, they are equal to the square of the longest side of the triangle. This little animation will show you what that looks like. So we squared the two smaller sides, and now we're moving those into the larger square, and you can see they both fit. The way that that theorem looks when we write it is right here. So these three sides are labeled A, B, and C. C is the longest side, and notice that it's also opposite the right angle in the right triangle. A squared, right here, plus B squared is equal to C squared. So the squares of the two short sides added together is equal to the square of the largest size. Another way that you can prove this to yourself is by looking at this tool. And what we can do is take the square of this side, which is B, and put it in the middle of the square of the longest side, which is C, and then we'll take apart the square of the other short side and put it in just like puzzle pieces. And you can see that, yes, the area of the two shorter sides fits into the area of the longest side. Even if we change around the size of the triangle, so let's say we shorten one of the sides so that we've got B is the shortest side, A is the next shortest side, and then C is the longest side. So let's see if this works. We'll take this, pop it in, and start popping in these pieces. And again, we should be able to fit all of these in here and prove that even though we have a different triangle, it still has a right angle, and we can fit the sum of this side and this side into this side. So the formal definition of Pythagoras' theorem is, in a right-angled triangle, the square of the hypotenuse, and the hypotenuse is another way of saying the longest side, is equal to the sum, and remember, sum means when you're adding two things together, the sum of the squares of the other two sides. Here's another diagram that helps you to see that. So in this case, we're using what we call a 3, 4, 5 triangle. It's another right triangle. It just happens to have sides that measure 3, 4, and 5. And if we square the two shorter sides, which becomes 9 and 16, and then add them up together, they will equal 25. So 3 squared plus 4 squared is equal to 5 squared, or 9 plus 16 is equal to 25. So this is a relationship that works for any right triangle. And just as the Pythagorean theorem works, whenever you have a right triangle, if you are able to take the numbers and the Pythagorean theorem works, as in they are equal, then you know that you have a right triangle.